The problem from Edgenuity states, a pencil rolls off a desk that is 0.76 meters tall. If the pencil hits the floor 0.32 meters from the base of the desk, how fast was the pencil rolling? What is known to us is delta y and delta x, and we can get that from the problem. What is unknown is v sub x. V sub x is equal to velocity. Another important thing to know is a sub y. A sub y equals negative gravity. Since the pencil is rolling down, taking a look at the formulas from Edgenuity, it shows that delta x equals v sub x times delta t. And by the way, delta simply means change in. Another formula that's given is delta y equals 1/2 times a sub y times delta t squared. To solve this problem, we will be using both formulas. However, we will need to rearrange them. Keep in mind that we're solving for velocity. However, in order to solve for velocity, we need the time, which is why we will rearrange the second equation to isolate delta t. We can do that by first removing this 1/2 that we have here. Just to let you guys know, in order to get rid of a 1/2, you would want to reciprocate it by multiplying both sides or everything, the whole equation, by 2. As we know, taking a whole number, making it into a fraction, we just put it over 1, and 1 times 2 equals 2. 2 times 1 equals 2, so therefore we get 2 over 2, which is equivalent to 1. That whole process simply isolates 1/2. So, moving on, we will continue by multiplying both sides or the whole equation by 2. I stated previously that will isolate the 1/2. However, since what you do to one side you have to do to the other side, that will leave you with 2 times delta y equals a sub y times delta t squared. Now we have to isolate a sub y. We can do this by dividing the whole equation, or both sides, by a sub y. That'll leave us with 2 times delta y divided by a sub y is equivalent to delta t squared. So now we have to get rid of the square, this 2. Since all that we want is the time, we don't want time squared. In order to do that, we have to take the square root of the whole equation, or of both sides. What that's going to do is it's going to take the square root on the right-hand side and cancel out the square, leaving us with the only square root on the left-hand side. Using this formula, we can solve for time and make a connection between velocity and delta t. Again, we need delta t in order to solve for v sub x. Do keep in mind that we will still be using this formula. Back to our edited equation. All we have to do from here is plug in what we're given. So our delta y, which is in purple above, will go where you see delta y in the equation. Our a sub y will also be replaced by negative gravity. Negative gravity is equivalent to negative 9.8 meters per second squared. Now I'm just going to plug that in and add the units to keep track of them. Now we can simplify by multiplying 2 and negative 0.76 meters, and out we will get negative 1.52 meters. My apologies for not putting the units. And we can't forget about our negative 9.8 meters per second squared, which is also known as our gravity. Negative 1.52 divided by negative 9.8 is equivalent to about 0.155. We know that the quotient is positive because a negative times a negative equals a positive. And that can be demonstrated by this triangle diagram being drawn here. It just lets you know that a positive times a negative will result in a negative, and a negative times a negative will give you a positive. Now we can take the square root of 0.155 and so on and get delta t. Delta t is equivalent to our time, which is 0.394 or just 0.39 seconds. Now for the moment we've all been waiting for, solving for our velocity. In order to solve for velocity, we'll need to use this equation. And just as our previous formula, we'll need to manipulate this formula as well, because we want to solve for the velocity, which means that's what we have to isolate or get by itself. Start by dividing the whole equation or both sides by delta t. As a result, you should get delta x divided by delta t is equivalent to velocity, aka v sub x. These equations are the same, just rearranged to solve for velocity instead of delta x. Here, I'm just rewriting the equation with v sub x going in front of the equation sign instead of behind it. Now, we can substitute information for our equation. In order to solve for v sub x, we can go back to our problem where we see delta x is given information. It's the one color-coded in yellow, 0.32 meters. And then for our denominator, realize that we're taking our answer for delta t and plugging it in. Now we have velocity is equivalent to 0.32 meters divided by 0.39 seconds. The fact that we have meters over seconds lets us know that our result is going to be in meters per second. And now we have our answer. Velocity is equivalent to 0.82 meters per second. Congratulations, we did it! Quick tip, a way you can tell the difference between delta y and delta x is delta y will be changed in the y-axis and delta x will be changed in the x-axis. You deserve a heart, a check mark, and a smiley face. Bye guys, enjoy your day.